Okay, both away, please. Conversations quiet. Conversations quiet, please. Okay, so already on your paper, you should have slope for the rate of change.
Hey, what's up, too?
And what did you write down for slope? Tighten. Rise over run. What else did you write up here? Good. What'd you say? Yeah. Over the change in X. Change in Y. Over the change in X. Okay. You should have gotten that from the video as well as this formula. When we're dealing with formulas this chapter, the M is what we use for slope. Like y equals mx plus b, we're talking about the M is the slope. Okay, you should be writing this down.
Don't go down yet. No, I'm still writing. No, I'm still writing. You dare, 3, 2, 1.
Okay, so let me give you an example. We have two separate slopes. We have two separate slopes here that have zeros somewhere in the slope. If I had something like this, if I plugged in some points, 2 points, and I ended up with 0 over 2, what does that equal? If you put it in your calculator, 0 divided by 2 is 0. Okay? It's okay to have a slope of 0. Okay, I'll wait for conversations to be quiet. It's okay to have a slope of 0. You can only have a slope of 0 if the 0 is on top. Okay? If my 0 ends up on the top of the fraction, then my slope is 0. Okay? If the slope ends up with the 0 on the bottom, you cannot divide by 0. If you do that in your calculator, 2 divided by 0, what do you get? Error. It doesn't equal 2. This one is undefined because you cannot divide by 0. Okay? That's fine. It equals 0. Okay? So if I were to label my points here, and we're going to do this in a second so you'll know how to do this. But if I plug into this formula, okay, there shouldn't be any talking right now. If I plug into this formula, it says that I'm subtracting the y's on top, and I'm subtracting the x's on the bottom. This would give you 0 over 5. So whenever you have a horizontal line, it doesn't matter if it's up here or down here, it doesn't matter where it is on the graph. If you have a horizontal line, m equals 0. Horizontal line, Titan, have a seat. Write this down, Marco. Titan, have a seat, please. Okay, if I were to plug in these numbers over here, my y value minus my other y value, x minus my x. Minus is always part of the formula, so when I'm plugging in a negative, what happens to my sign here? Yeah, they both go to positive or add. What's negative 2 plus 2? 0. Cannot have the 0 on the bottom.
Yeah. That's cool.
So this one is undefined. Okay? Notice that it's a vertical line. So a vertical line is always an undefined slope. A horizontal line is always a slope of 0. Lots of people last period lost points because they didn't have any of this written down. Okay, so then we can use a table to find the rate of change. What did we say the rate of change is? What's another word for the rate of change?
Slope.
The slope. The same thing. So this tells us the distance the marching band marches over time. Okay? So how much is the time going up each?
60 seconds each.
Okay, so it's going up by, let's say, a minute, because we're in minutes here. And is it going up by the same amount over here?
No. What? Yeah.
Try it. Use your calculator. How much is it going up, Keegan?
60 each.
Not 60.
Yeah.
260 each.
260, right? Okay? If you add 260 each time, it's going to give you that. Okay? So, is the rate of change constant?
Yeah.
Yes, because we're going up by a minute here and we're going up by 260 feet over here. So, you need to have this written down. The rate of change is constant. Because time and distance increase the same amount. Each time. Okay? Okay, so how could we use our slope formula, change in y over the change in x? How can we use our chart information to come up with some sort of a slope or a rate of change? How much is the y changing each time?
1.
Remember, the y is over here. How much is it going up each time? 260. 260 feet. And what's the time going up by? 1 minute. So could we say that the band marches 260 feet per minute?
Yeah, so quick.
Yeah.
Are they?
Okay, make sure you have this down on your paper. Okay, now how do you think which of those, change in y over change in x or rise over run, which one do you think we're going to use if we have a graph? Rise over run.
Oh, that was a guess.
Because we're just going to count it. Okay? So you can choose any 2 points. They've chosen a couple of points for us here, but I could have chosen this point and this point up here. It doesn't matter. It'll all reduce to the same amount. So if I'm counting the rise over the run, I want to get from this point to this point. How much am I rising? 2. And how much am I running? 3. Are they both positive? I'm going up, that's positive, and I'm going to the right, that's positive. So my slope is 2 over 3. Okay? Same thing here. I've chosen 2 points. My rise is how many? 4. Am I going up or down? What does that do to my number? -4. And how many am I going over? 5. 5. So -4/5. Okay. Again, you can pick any 2 points. You might get numbers larger than this, but they'll reduce to this. Okay? What? If we have only points and no graph, what do you think we're going to use? The formula, right? Yeah. Okay, Sophie? Yes, Sophie. What could we use? Okay, so we're going to label our points first with an X1, X1 and a Y1. Remember those numbers? Those numbers are just a way for me to say that these 2 go together in the same pair. And then these 2 go together in the same pair. Okay, I'll wait. I'm on the last problem. No, I need everybody quiet. Okay, So what is my y2 number? I'm taking out these labels and putting in a number for it. What's y2? -2. Minus is always the formula. And my y1 is 0. Does everybody see that? Okay. x2, what's my x2 number?
-2.
Nope.
3.
3.
3.
Minus
-1.
-1. Make sure that you put minus a negative. Don't try and do it in your head because you could make a mistake. What happens to these? -2 minus 0 and 3 plus 1. Can we reduce this?
Yes.
2?
-1/2.
Thank you.
I need to go with that.